So first, just to show you, this is just, you can see my code here. It's just, let's see, it is 70 lines of code. So all it's going to do is read in a file, and it's going to do a 3D plot, which is cool. It's going to do, you've done scatter plots, right? Two-dimensional. This is three-dimensional. And so let me run it, because that's probably the easiest way to explain what it's doing. So this is our favorite video, which is the BLEP. Here it is. So there's the BLEP video. And then this is the three-dimensional plot. And now you've done feature extraction, right? That's part of your homework. And so I have three of the features that we've extracted. I have area, texture, and aspect ratio. And what I'm doing is, here's the video of the plankton swimming. And what I've done is color code them. And you notice, first, I just love 3D plots. So what we're looking at is the video is like 30 seconds long. So each dot is one object in one frame. And I've gone ahead in the future. What you'll learn is something called clustering. I told this clustering program, I have three variables: area, texture, and aspect ratio. Can you make 5 groups out of it? And through the magic of clustering that you'll learn about in a few weeks, what this program did was say, oh, well, I'm going to cluster all the tiny things that have small aspect ratios into a group called purple, which is group 3. And if it has a lot of texture, I'm going to make it group 1. So this was automatically done, automatically classified. And now if we look at the plankton, like look at this yellow and blue. So now the swimming, this is the Blepharisma, it's going between yellow and blue classes. And so yellow class has a lot of area. And now I'm going to turn the curve, and we can look at, this is the beautiful thing about 3D plots. So we notice that the yellow has lots of area, and it has modest texture, not much. It's mostly on the low side. And then if we look at these two groups up here, the Christmas colors, I call them, the red and green, it has a very high aspect ratio. And Blepharisma has a very high aspect ratio. So let me run it again. So let's look at aspect ratio. I'm going to tilt the curve. With my mouse, I'm just grabbing it. So let's look at area versus texture. I'm sorry, area versus aspect ratio. So up here, aspect ratio is 3 to 5. We know from our study of pens, pens have a very high aspect ratio. So anything that's long like a cigar is going to be up here. So red and green, and look who's red and green, the Blepharisma. It's popping between those two classes of red and green. And what's the difference between red and green? Well, let's see. They're very similar. I don't know how it's telling those apart. Yeah, red and green is all out here too. Anyway, so in conclusion, what this is doing is, you know how to do the feature extraction. You're doing that for your homework. The new thing here is we can plot. Forget about colors for a second. You can do this plot for every creature, every object in every frame. You can plot in this three-dimensional plot. And you can see kind of clusters forming, right? You can see there's a group that's very much over here. You can see another group out here where they're, let's see, very large area. The magic that you haven't done yet is how you can automatically classify. And that's the holy grail here. What we'd love to have is that the Blepharisma always is in the same class. The algae is in another class. And this is a technique called clustering by nearest neighbors we'll get to in a few weeks. But this is where we're headed. And what I spend a lot of my time on is trying to get these classifications correct. And the name of the game is to get features that help separate things. Like, for example, you see all this is very dense around here. They're all kind of clustered together. And if we were to just look at area, I'm going to look down on the curve. There are a lot of different creatures that are small. And that's why you need another dimension to pull them apart. And so when you use another dimension like aspect ratio, you can see now we can separate tiny things based on aspect ratio. Tiny things which have big aspect ratio are probably baby blepharisma. All right, that's a lot to throw at you. I'm not going to ask you to code this right now, but I just want to show you where we're heading and why clustering is a cool technique where it can automatically put things in group if you have features that distinguish the groups. Okay, any questions on this? Again, this isn't homework. This is just to show you what I do for my day job. You know, this can work for balloons, as Professor Kulkarni showed you. It can work for people, objects in your room, anything that has features, and you can figure out what features are important and you can measure them and quantify them, then this method works.
I want to ask a quick question.
Sure.
To the students, which is, what do these dots in that beautiful 3D plot, what does a data point, a dot, represent from the image?
Is it like one object for each frame?
Perfect.
Right? Yes.
So how many dots would there be if there's an average of 10 objects per frame and 100 frames?
1,000?
You got it. So there are a lot of dots here. I did it for, I think, 30 seconds. So that's 900 frames, 30 frames a second. And there's probably around 10 objects per frame. So there are about 10,000 dots there. And it, renders pretty fast. When I was a boy, you couldn't do this on a home. There weren't home computers, but I mean, just to give you a perspective, this is nothing to you, but for someone who's been around for a long time to be able to do this in relative real time on a home computer is quite amazing.
Yeah. So there, for a given object, Tom, there could be multiple dots representing the same object here, right? Because we have multiple frames. There's the temporal aspect that's kind of not on these 3 dimensions.
Exactly. And for my next trick I'll do is have the movie running and in real time place each object in this feature space.